Um, are you based here in Finland?
Yeah,
Or-
based here in Finland. Yeah.
Okay, cool. Doing research on malware.
Yeah, malware and how it behaves. Naughty malware. Yeah.
Okay. Naughty malware. Is
Yeah.
there also nice malware? Good
well,
malware.
sometimes there are.
Okay.
Interesting ones at least.
Leveraging your CPU power for the good of humanity.
Yeah.
I have to encounter that one still. Okay, so please give a round of applause for Matteo from F-Secure.
Okay, so I'm definitely aware I'm the last man standing between you and the beers. I'll try to be fast and hopefully interesting enough. As already said, I'm from F-Secure, from the F-Secure Labs. The F-Secure Labs is the department where most of the security technology are designed, developed, and operated within F-Secure. We're talking not only about the engines which run on the antivirus clients which we install on our customers, but also all the backends and all the automation which runs on our side and supports every day our researchers, our analysts, our business. So basically, when I've asked to give some talk, I used to start, telling people that actually malware is out there, exists. It's bad, but luckily, since 1 year or something, due to the last IT security escalation we saw, and Edward Snowden and so on, the media attention, the media focus has moved more on this topic, which means people are getting more aware, and luckily I can skip this boring part and get more to the beef. So, how do we analyze malware? There are mainly two main strategies. The first one consists of looking inside the sample. With sample, we usually refer both as file or URL. You look inside the sample and you try to find what are referred as signatures, which are strings, ASCII characters, or code snippets, which usually are known to belong to a certain malware family. This is the easiest strategy. It's the fastest strategy actually, and it's very effective, but it's also very easy to evade. Code obfuscation or encryption are very good techniques, which prevents this kind of from working. And then we have the second strategy, which is probably the thrilling most one, which consists of double-clicking the file. You double-click the file and you look what happens, right? So, of course, there are some security concerns, some precaution needs to be taken, and the way it is usually done is via sandboxing. Sandboxing means providing a very closed environment in which you can run your unknown object, URL or file, your unknown code. And in this specific scope, the requirements are to be as close as possible to a real computer, so that malware could behave as naturally as possible, like it would be in its own, environment. And what you can get when you run malware? Well, you can get things like this. Sometimes it shows up very easily. In this case, we see ransomware is a very prevalent threat nowadays. Once it gets hold on your computer, encrypts all the data, and then ask for a ransom to be paid. In this case, you can see within 95 hours. If the ransom is not paid, deletes the encryption key and all your data is lost. How much a ransom usually costs? Between $200 to $500. We have last month a couple of very critical cases where a variant of, not this one in particular, but a variant of this one infected 2 hospitals in USA, and the total ransom was over $1 million per hospital because it infected multiple computers, and in order to get back the data of their patient, they had to pay the ransom. Funnily enough, or interestingly enough, I'm usually asked, like, if you pay, do you get your data back? Well, it's in the criminal's interest to do so. So it might be by chance that you don't get it, but it's in their interest that you can trust them once they infect you. It's in their interest that that paying, you get your files back. Some of these, for example, this variant was offering very nice customer care in case you were having issues once you paid. And then we can get way more interesting information, such as this one. Here we can see a PDF containing what claims to be some annotation for a a summit about Russia held in Brussels in 2010, what that PDF was really containing was an exploit which would have installed a RAT, remote access tool, within the victim's computer, and it would start exfiltrating all the information possible. In this case, was a high-profile targeted attack, and we usually don't know the victims, or if we know the victims, because they contact us, we cannot disclose them. But from these sort of in pieces, we can understand who might the victim be and what the criminal might be after. In this case, someone related to some government association. What else we can get? Well, we can get, of course, threat intelligence data. Once you see the behavior of a sample, you can group the samples, you can group the malware based on their behavior, and you can track the evolution of this behavior over the years, which means you can see which interesting features they're adding to those malware and how they actually evolve. Some malware variant might evolve during several years. Conficker, for example, evolved for more than 5 years. You can build automated detection based on what we call indicator of compromise. Indicator of compromise, we're going to see some example later on, are events or traces within a system or a network which clearly show that there's something wrong. And you can analyze this indicator of compromise, cluster those, and come up with conclusions, with detections. And then also, we can do a lot of intelligence gathering, which might not be strictly related to that specific sample, but it's very important for us. So when you run a sample, some file will be dropped. Those are interesting. Some URL will be visited. Those are interesting. They usually call home. They contact what we call command and control servers, which usually distribute updates or instruction, or where they actually upload the stolen data. And of course, knowing these IP addresses is relevant because we can blacklist those IP addresses as soon as possible. For example, network traffic, we can get, I don't know, encryption keys from memory and so on, you name it. There's a lot of things we can get. Let's look at an example here. We're talking about file system activity. So on the top there, you can see that in the user folder, there's a Google update.exe file created there. It's an executable. And then just below, there's a desktop ini file created in the Windows folder. Desktop ini files are usually text file, which in Windows describe the content of a folder. But if we look at the type, is a DLL, is a library, which is tried to be hidden as an text file. And among the deleted, that's obvious. It deletes Windows Defender, which is the operating system antivirus, the antivirus provided by Microsoft in its modern operating system. If you would have other operating system installed there, it would delete each and every executable there. So that is a clear indicator of compromise. And on the network, this is another malware. It tries to resolve that domain jmaxmine.com. It's actually a legitimate domain. Provide geolocation based on your IP. The malware is trying to understand where the victim is, and underneath there's an unknown. We cannot understand what that DNS request is, and the reason why is that they're abusing the DNS protocol in order to pass under the radar. They're actually calling home. That's an IP of a command and control machine, and they're using the DNS protocol, the DNS headers, in order to pass over firewalls or whatever. But they're actually having a completely different information flowing. That's why the parser fails detecting which type of DNS. Last but not least, sends a lot of UDP a lot of UDP packets over what they look like random addresses. It's trying to join a peer-to-peer network. So it's trying to contact a lot of other infected nodes in order to join a peer-to-peer network. So this is an example of what type of information we can get from these systems. F-Secure started building around 2006 the first prototype of automatic behavioral analysis platform based on Sandbox. At the time, the use case was way simpler. The analyst and the researcher wanted a one-click way to send samples, files there, and see how they were behaving. But the platform proved to be quite effective, and we soon integrated within our automation. And now, for more than 10 years, I've been supporting our business quite effectively. It is based on VMware and was supporting Windows, Android, And Mark, you can see here the sentence how this is the original when it was proposed to the managers. This is what the idea they were selling. And the problem we are facing nowadays with the current architecture, it's a monolithic architecture, is due to the fact that we cannot really scale feature-wise anymore. If you think about it, it's quite of a complex system. We're talking about a sandbox where multiple fields of expertise are cooperating together, right? We have network forensic analysis, we have file system memory forensic analysis, flow of execution forensic analysis. A lot of different people need to work on the same architecture, and this made the development cost grow more and more. So a few years back, we decided to basically reinvent the wheel. We decided to rewrite the architecture, trying to tackle from the engineering perspective, tackle the problem. And we came out with what we call C. C is a small Python framework thought for sandbox-based test automation development. It's an asynchronous framework, and in short allows you to provide two different configuration files, one for describing the sandbox. So let's say you want Windows 764 with 2 CPUs, I don't know, 4 GB of memory, you name it. And the second configuration file instead allows you to choose which hooks or plugins to use. And this is where actually the field of expertise can focus without the need of knowing the entire architecture anymore. But via writing small plugins, well isolated, the developer can provide their expertise, that they can add their expertise within the platform, and the end user can decide whether to use those in for the given test case. Like pretty much like playing with Lego, right? You pick up which plugins you want to use, and then you deploy the sandbox, and C will take care of its execution. To give a more concrete example, one way you can actually drive the entire execution is via defining a protocol, which you see on the left. So you define what is going to happen. The machine is powered off. Powered on. Sorry. We wait for the guest operating system to come up. At that point, you inject a sample. You wait a certain amount of time to allow the sample, to behave, and then you power off the machine. And the protocol is then or better, the transportation is realized by the events which are delivering the information to your plugins, which can react. Okay, the machine is now on. I can start doing this. I can start doing that. The guest operating system, or even better, the sample has been injected. It's time to start, tracing what happens on the network, and so on and so forth. It proved to be quite effective in decreasing our development cost. C is open source. Here you can find some references if you're interested in the project. And one, like, let's say, the reason why we came out with the idea of open sourcing C, and why we started talking openly about sandboxing and stuff like that. MAP used to be a sort of a corporation secrecy within our company since few months back. It has been one of the reasons why we had an edge on our competitors. The reason why we decided to open is due to the fact that people started realizing the importance of sandboxes in order to analyze malware. To give an example how a company could benefit from something like that, you could basically scan each and every attachment that your company email exchange is receiving before delivering to your end employee or to your end customer. And we see more and more companies and startups which are providing their own sandbox. And since we've been doing this for 10 years, we decided to step into the game and take a lead position into the field. What we want to do is to provide the next generation sort of sandbox or behavioral analysis platform for our customer, bringing disruptive innovation, this is how they say usually, into the field. And we wanted to provide these as a product, so the companies can actually subscribe, and they can send their URLs or their emails attachment, and they will get back their behavior, and if they want, they can get back also our opinion about the behavior itself. And we have, few ideas how we could actually bring disruptive innovation into this field. One is via employing what is referred usually as virtual machine introspections tools. What usually happens is that in the traditional sandboxing, you deploy the guest operating system, which is heavily instrumented. There are debuggers, there are tracers, there's a lot of software running all together with the malware and spying the malware from within. Now, as virtual machines are usually providing a virtual disk, virtual memory, the CPU is actually not virtual network. Why not using all these resources and trying to make the sense out of the behavior, out of the machine itself, rather than deploying a tracer within the guest? From a sort of a, let's say, academical point of view, when you're running a test, if you're polluting the test environment, you know that you cannot trust 100% that data. And in this case, we're talking about malware which might actually be aware of your debuggers, and they might even tamper the actual output, preventing you from making the right decision. And we see this happening in the 10 years. We see this happening a lot of times. Then we want to provide high level of tailorization on the customer, because when we talk about these governmental malware or these targeted attacks, we saw in the PDF before, they're highly tailored on the customer. We saw malware which activates only if it's executed on the victim's computer. They check the IP, where the computers are, the IP range of the computer. They know their victims and they look for their victims only. They will activate only if the victims are the one running the malware. So we of course need to provide a heavily tailored or highly customizable, at least, sandbox based on which customer we are, of course, dealing with. And then we want, of course, cloud deployment. So does anybody of you know, for example, VirusTotal is a portal where you upload your files and they scan with a lot of multiple antivirus engines. We want to do something similar, so easy to send samples and URLs, and we will give you back the behavior. But some customer cannot actually put their own data on the internet. They have strict restrictions when we talk about governments, organization, and customer of this type. We want to have also an on-premise deployment, so that what they will end up getting is a sealed box. They can send the malware there, or they can send what they suspect being malware there and get our opinion back. So this is what we are building right now. So basically productizing in a better way what we've been running for more than 10 years. And well, I guess that's it. So thank you for listening, and if you have any question, or you can drop an email over there.
It really sounds like the Volkswagen software, which doesn't emit as much when it's running the test bench.
Yeah.
So you really say that now the malware detects that it's like running on your...
There's a lot of... It's not new to the criminals and to the malware authors that AV industry is using Sandboxes in order to... Because even if you do it manually, it's a very cheap... If you run manually a malware on your computer, then you need to re-image in the hardware, which is quite expensive. If you use, for example, VMware, you create your own virtual machine and you double-click the malware there. So criminals know that, and they use a lot of different techniques in order to detect that they're running on a test bench. First thing they look at is, are you using tools like Procmon or any debugger? Is the CPU debugger flag turned on or stuff like that? At that point, they might behave in two different ways. The most common one, they commit suicide. They just disappear. They vanish. They don't show anything. But some of them try to damage you back. So they start burning all the CPU, filling all the memory or stuff like that. Just for to have fun with you. Yeah.
It's a bit of a rat race.
Yeah.
Okay. Question. Do you have a question? Oh, sorry. Search.
First of all, thanks for the presentation. It was really interesting.
Thank you.
It's also a problem that we are facing from the other side. So from a media or publisher perspective, we are sometimes the ones spreading stuff that we are not aware of through basically advertising and things like that. Do you also have
I
experience?
remember that case.
Yeah,
I know
we
which
had-
case you're
we
talking
had
about.
one in the Netherlands also 2 weeks ago. This time they actually arrested the guys, so
Mm.
that's a good thing. But do you also have experience with your technique and use it for things like that? Is it
So using our technique to detect
Yeah.
sort of tampered, for example, website or stuff like that?
Yeah, because
Or-
the challenge we have is that this advertising is, of course, we provide basically the opening
Yeah, sure.
to serve the advertising, but
The-
there's a lot of stuff happening,
Yeah.
let's say, outside our influence.
Yeah.
and
Like in your case, what we're talking about is usually people getting hold on the advertising companies, which you're just outsourcing the advertise to, and then you're not actually directly involved. But it happens that someone opens your web page and you're serving malware, even though you haven't been compromised. What has been compromised is the advertising company. We had a case like that. I think was Helsinki Sanomat or something like that, which was serving malware, and we saw that they tremendous spike in our antivirus. Which we were scared about. We were scared of false positives that day. Was pretty hectic for us as well. Of course, you can do it. What you could do is, for example, scan every hour, every half an hour your website with a solution like that and see if it gets compromised. That's something you could definitely do it. Like the idea is that there will be, of course, also scriptable API so that you could do it via scripting against that. Yeah.
That's a bit of the problem, because with the advertising, you don't even have to hack the ad server.
Yeah.
You can just buy like
Also.
good ad space and
Yeah.
just have proper targeting in there.
Yeah.
And just target like really specific IP ranges or browser versions or whatever.
That's
So it
usually
even limits
referred
your
as
spend as the
Yeah,
criminal.
that's referred as watering hole attack, and it's very tricky because you might visit many of them especially when it's a matter of targeted attack. They trigger when the victim comes from not only from a country but from a company, and this is the way they do when for example a company is very resilient. A victim is very resilient to spear phishing attacks, so they'll send a lot of documents as I showed before, and the guy is not actually falling into the trick. Then they start studying its browsing behavior, and they compromise a given website. But how then they hide from us, from F-Secure, for example, that exploit triggers only if the victim is visiting it. So if we as F-Secure don't visit it, it's going to give a totally different content, and that's tricky. Of course, it can be solved with a solution like this one, via using proxy, for example, or stuff like that. The problem is always you need to know the victim. You need to be the victim, and who is going to be the next victim? Do you know? If you do, please tell us, because that's
Because
important.
also for us, that solution would not make that much sense, because the virus or the malware is injected like after it left our premise. It's
exactly.
completely inserted via the JavaScript from the
Yeah.
server. So our clients, our users, have to install the proxy
Yeah.
to
trigger
leverage
that.
this
Yeah.
advantage.
But this solution can definitely tackle these type of problems as well.
Because it would be really be a market to have something like what New Relic is providing, which is like really injects like a lot of JavaScript to the client.
Exactly.
And then from that JavaScript,
Downloads the payload.
encapsulate
and
like a virus scanner in JavaScript.
Yeah.
It will make it really heavy, but
It's definitely something that this solution can tackle easily. Yeah.
okay. Maybe for the next hackathon of the future of advertising. Timo. I would have been disappointed if you didn't ask. a
Okay,
question about
all right. One or two questions actually. The first one, so how much you use sort of larger scale statistical methods to sort of aggregate or work on the aggregate results in the cloud, basically, that your endpoints report to, and is that sort of then an advantage? And then secondly, can you characterize the sort of the sandboxes of various security vendors, firewalls and whatnot these days have those that are they any good?
Let's say that's well, the first question, if I got it right, is if we are aggregating statistics coming from our endpoints, right? Indeed we do, and that was a critical turn into when we made a decision of providing a distributed reputation service. That's what we do. So basically, our clients, all our systems can query our headquarters and ask, what do you know about this? What do you know about that? And that gives us the global scale visibility, which a single antivirus product would not have. So to give an example, you might see that now we are getting a lot of queries against a given file. That's most probably, and if it's coming from a specific geographic region where it's, for example, 7 o'clock in the morning, that's most probably a Windows update, right? That's something that an antivirus would never be able to do. They get a tricky executable, which is coming in their computer. They try to look at it and looks really tricky because Microsoft does a lot of tricky stuff, according to an antivirus product at least. It's a 50% probability. Do I block it and it's a false positive and then I will get a lot of troubles? Or do I let it go and I might expose my customer? But if you have the global visibility of the behavior, malware spreads aggressively but is always way slower than most of the legitimate sort of files or URLs. So yes, we do a lot. We anonymize a lot due to our policies. So we don't know who is querying us. We just collect the geolocation and then we drop all the rest of the information. Well, for privacy reasons, of course, but is a very important information for us. And we have statistics. We have even on the website we have a world map where you can see actually how the malware is spreading around the globe, coming live from our data. I can show you later if you're interested. Competitor sandboxes. Well, FireEye is the most known one. Yeah, but I don't like to make big statements. For what I know, behind the scene they're using Cuckoo Sandbox, which is open source technology started more or less when C started. The difference between C and Cuckoo Sandbox is that Cuckoo Sandbox is sort of full-blown solution, while C is a framework to you could use C to develop Cuckoo Sandbox basically. And Cuckoo Sandbox is very much alike our map a few years back. So I'm following actively their development and their issues, and they are facing problems which we faced long ago. So I hope this is an answer. I mean, I think we are a bit ahead on that, on the development, because we have big expertise. On the other side, yeah, I don't really have numbers, and I don't like to make strong statements like that technology is way back or stuff like that. But there are very promising research ongoing in that area. There are a few startups which are producing something which is extremely interesting for us. In many other cases is what I would refer to a first generation sandbox. And FireEye, I think, is a first generation sandbox. So what used to be MAP a few years ago. Yeah.
Cool.
Yeah, one question. What about these phones? Can you sandbox phones at the moment?
We have an Android-based sandbox, and yes, we do. It's a bit tricky in a sense that the mobile phone malware. The main challenge is that due to especially Android, internals requires user interaction. So and it might be with different interfaces. So sometimes doing the extra step to trigger the malware might be actually tricky. A lot of malware on Android is actually coming from what we would refer as potentially unwanted application, which the user ends up installing willingly without knowing that there's something extra inside. And automating that is a challenge. But for the rest, we are pretty good at detecting malware on Android platforms, for example. So without any issue, yeah.
iOS and Windows Phone?
Windows Phone, is there anybody apart from me having a Windows Phone actually? Because I don't like let's say that Windows Phone, there's not the market, not at the moment. Sorry? iOS is there's very little malware on iOS, because the difference between Android and iOS is that, or iOS intended as the mobile phone, because for Mac, for computers, we start seeing something. But for iOS, the fact that there's only one app market, as I said, most of the malware on Android comes from these third-party markets, which don't do a very strict control, don't apply very strict control policies. The fact that iOS has only iTunes, is it iTunes, I guess, is makes so that it has happened, but it's very difficult to sneak malware into iOS phone, at least for now. So there's not the demand for that, at least. Yeah.
Timo, are you now going to say something about something nice about Windows Phone, or that it doesn't? Lot.
Yeah. Yeah, like
A short summary for the people at home. It has a great security model. Unfortunately, no one uses it.
Yeah. No, apart from jokes, like the point is that this platform requires a lot of maintenance anyway, and therefore there's a strong need from the market, and iOS at the moment and Windows Phone are not there's not such a strong need for having a sandboxing scanning. With this current solution, we scan tens of thousands, if not hundreds of thousands of samples every day. There's not such a need there's not such a volume, therefore there's not the need to invest in that direction. The expensive part is, of course, the scanner. As you might guess, you get a memory snapshot of a Windows machine, the memory looks completely different from an Android, and you need to completely build two different forensic tools, which are expensive.
Okay. Final question.
We can discuss in front of a beer afterward. Yeah.
Hey, so you're talking about doing sandboxing as a service.
Yeah.
It was my understanding that FCQ was operating a red network type scenario where they have segregated sandboxes specifically for malware, and if you're bringing that to on-premise solutions with customers, they're not necessarily going to have the same expertise, and then they're going to taint their network.
Of course, we will. First, we need to consider the different use case. In the red network, where we have our own sandbox, nowadays we have multiple sandboxes running. We are explicitly running malware. We are hunting for malware in there. When we think instead of a solution deployed on-premise for our customers, what their customers will end up running is not malware. It's going to be emails attachments. It's going to be URLs, which they're going to be anyway running within their company, right? I mean, if you think about the scenario, as long as they don't really want, they won't go to hunt down for malware out there to use within our sandbox. Most of the cases, they will use our sandbox to validate what they're about to run on their real computers. So there will be, of course, training and knowledge share how to operate this machine, because it's anyway tricky business to run, but is not as complex or as dangerous as our use case, in which we explicitly know that these 100,000 files are malicious, and we're gonna send as a batch within few nodes and run them. So it's a bit different. They don't need a real red network in order to operate an on-premise solution, let's say.
And as a secondary thing, if you have zero-day hypervisor escapes, you could taint the hypervisors themselves and then have malware, which is allowing malware through. Because
that's why we have the red network.
So, but for a customer, if they have like bad BIOS, so the BIOS gets overwritten, or if the firmware and the chips get overwritten, then their kind of sandbox networks gets defunct. And kind of how do you mitigate that for customers? Because the F-Secure software says it's clean because of the malware, so it's hard.
Of course,
we
will. Of course, we are having straight thread modeling against this sort of solution. When it will come out, it will be secure enough. Let's say we are aware, of course, of the risk, and that what probably the advanced threat actors will try to jump out of the sandbox, especially to detect whether they are running on a real sandbox. There's no clear answer if not you secure that thing as much as you can by using trusted execution, hardware monitoring, and tools like that in order to detect if the malware jumps off. the hope or the idea is that anyway, if something that drastic happens, it's pretty evident. It screams pretty loud, so it's easier to detect. They need to really exploit, and what usually ends up happening is that they crash the hypervisor. So there are events. They are events which are pretty noticeable anyway. So at that point, good monitoring on top of the thing, and being aware of the risk, of course. There's always a risk.
And do you have any recommendations in terms of time-based attacks? Because with Metasploit you have hypervisor checkers, and you also have time-based where you send the malware and it kind of installs but doesn't do anything, so it's a legitimate application, but then an update down the line then pulls in the actual malicious part.
This is the question: what is a legitimate application? If you run a document and is spawning a thread which is leaping, is that legitimate? That's the question. It's not always just doesn't do anything explicitly malicious. It's not enough to say doesn't do anything explicitly malicious in order for you to detect whether it is malicious or not. We have plenty of cases where you send, for example, a PDF file and doesn't even show the PDF because, I detected your sandbox, yes, but I'm expected to see a PDF, right? So that's enough to spot you back. And there are plenty of cases like that. Of course, timing attacks are difficult, but there are plenty of also solution you can use to overcome those. You provide let's say an NTP server, which is sending very aggressive updates over the time on your machine, or you're hooking the sleep request or stuff like that. So from both, you tackle the problem from both sides. First one, you always have a baseline, an expectation on how something clean should behave, and every deviation, even something which is not actually happening, is actually raising a flag for you. And on the other side, of course, you either instrument the guest operating system to prevent things from sleeping, or you hack the hypervisor clock, you hack the NTP server, or stuff like that, in order to prevent that.
Thanks. Yeah, so another round of applause for Matteo.
Thanks.
That was the final speaker for today. We'll be back in June in the Netherlands and probably here in Finland